So now as for the next question, here the question is a little different. Okay, here they're not asking us to find the current or voltage across any device. Here the question is to find the voltage source V. Let's read the question. Find the voltage V which causes the current I1 to be 0 in the network. So here in the question already I1, I2 and I3 are already marked, right? So they are asking us to find the voltage source V such that this value I1 becomes 0. Okay. So how do we do? So before now, I want you all just simply to pause this video and try to do this problem by yourself. Okay. And then see there are different methods of solving this problem, right? So maybe you can write the mesh equation and then finally you can put substitute I1 is equal to 0 and then you can find the value of V, right? Because anyway, like I said before, if how many unknown variables are there, let it be current or voltage or anything or resistor or anything, how many unknown variables are there, that many equations you need. So if there are 3 unknown variables, then there must be 3 equations. Like for in this example here, what are the unknown variables? If you look on this if you look in the circuit, we have I1, I2 and I3, but the value of I1 is already given, right? The value of I1 is already given, it is 0. So what are the remaining values to be known? I2 and I3 and also V, which means there are 3 unknown variables, I2, I3 and V, which means you need 3 equations to find the value of I2 and I3 and V. So if you have 3 equations only, then you can solve for I2, I3 and V. But the question is, but there is another the question is to just to find V, so you don't need to find I2 and I3. And also there is also another simpler method. What I prefer is to simply follow the procedures you have been doing for the previous problems. Just simply follow the same procedure. Okay, that's what I'm going to do. Okay, so you can do any way you want. All right, so this is how I'm going to solve this question. First, I'm going to, as usual, I'm going to express the equations of all the 3 meshes. Okay, equation for mesh 1 is, so here the I1 touches 6, 2 and 5. So 6 plus 2, 8, 8 plus 5, 13. So it is 13 I1 minus 2 I2 and minus 3, minus 5 I3. Minus 5 I3 is equal to, and as for the voltage source, the mesh 1 contains 2 voltage source, 20 volt and V. So if you look over here, this I1 is coming out of the positive terminal, which means this voltage source, this 20 volt is supporting I1, so it is plus 20, so it is 20. And whereas this V, this I1 is going into the positive terminal, which means this positive terminal is not creating I1, it is opposing I1, so therefore it is minus V. So this is the equation for mesh 1. Now the equation for mesh 2 is, so this is mesh 2 and here I2 is positive and the remaining current is negative, and here I1 touches this 2 ohm resistor, we have minus 2 I1, then we have I2 touches 2 plus 1 3, 3 plus 3 6, so plus 6 I2, and I3 touches only this resistor, so we have minus I3 is equal to, there is no voltage source anywhere over here in mesh 2, so it is 0. Now the equation for mesh 3 is, in mesh 3 we have here I3 is positive, I1 and I2 are considered negative, and also I1 touches only this resistor, so we have minus 5 I1 minus I2 plus, as for I3, 5 plus 1 6, 6 plus 4 10, we have 10 I3 is equal to, and there's a voltage source in mesh 3, right? This voltage source, and this I3 is flowing upwards. In this branch it is flowing upwards, which means this voltage source, this positive terminal of V is supporting I3, right? It is supplying I3, so it will be plus V. So these are the 3 equations. Then I'm going to express these 3 equations in matrix format. So writing the above equations in matrix form. So we have 13 minus 2 minus 5, 13 minus 2 minus 5. Next is minus 2, 6 minus 1, minus 2, 6 minus 1. Then we have minus 5 minus 1, 10, minus 5 minus 1, 10. And the current matrix is I1, I2 and I3. And the voltage source is 20 minus V, 0 V, right? Okay, so this much I did just like how I did in the previous problem. Now see what the question says, that find the voltage V, that's over here, which causes the current I1 to be 0. So we know that the value of I1 is equal to 0, right? So what is the equation for I1? What is the equation for I1? We know that I1 is actually equal to the determinant of the matrix in which the first column is replaced with this 20 minus V, 0 V. 20 minus V, 0 V. The second column is the same, minus 2, 6 minus 1, minus 2, 6 minus 1, minus 5 minus 1, 10, minus 5 minus 1, 10. And as for the denominator, it is the coefficient matrix, 13 minus 2 minus 5, 13 minus 2 minus 5, minus 2, 6 minus 1, minus 2, 6 minus 1, minus 5 minus 1, 10, minus 5 minus 1, 10 is equal to, and we know that according to the question I1 is equal to 0. So we know that this value is equal to 0, right? This is what it means. So this is how we do this problem, right? So here we know that 0 divided by any denominator is equal to 0, right? Or if we take this denominator into this side of the equation, 0 into this denominator is actually equal to 0, which means this is only possible if the numerator itself is equal to 0. The numerator itself is equal to 0, which means we don't have to even find the value of denominator, right? Because 0 divided by any denominator is equal to 0. 0 divided by 5 is 0. 0 divided by 3 is 0. 0 divided by 7.2 is 0. So this denominator doesn't matter. Or if you simply take this thing to this side of the equation, this determinant into 0 is also equal to 0. Therefore, this numerator is equal to 0, right? Which means 20 minus V, this is 60 and this is 1, so which means 60 minus 1 is 59. Minus of minus is plus, 2 into, we have 0, minus V becomes V, minus 5 into, and this is 0, and this is 6V becomes minus 6V equal to 0, right? What is 20 into 59? 1180, which means this is 1180 minus 59V plus 2V plus 30V is equal to 0, right? Or in other words, 1180, and here we have, let me see, this is, what is minus 59 plus 32 is minus 27. So we have minus 27V is equal to 0. Or in other words, minus 27V is equal to minus 1180, or V is equal to 1180 by 27, which is equal to, let me see, 1180 divided by 27, right? 1180 divided by 27 is 43.7. So the answer is 43.7 volt. This is the answer. Okay. So So there are different methods of doing this question, right? So here what I did is that I did the normal procedure. I followed this normal procedure how I did the previous problems, and then I equated the value of current I1 is equal to 0, right? So the other method what I said is, if you want, you'll have these three equations. Whatever, anyway, you'll be facing these three equations. So if you want, you can substitute the value of I1 over here as 0, and then you will have find the value of I2, I3, I2, I3, 0, and I2. So you will have three equations with three unknown variables. What are those three unknown variables? I2, I3, and B. So like that you can solve for B. But I believe that method is a little bit more longer when compared to this method. This is more straightforward. Okay.